Hey guys, welcome to FM200 of the Further Maths Fortify study guide. This question reads, there is a little known island called Squirrel Sanctuary in the middle of the Pacific Ocean. Let Bn be the number of nut trees on Squirrel Sanctuary at the end of year n. The change in the number of nut trees from year to year can be modeled by the recurrence relation, and then we're given this one here. Bn plus 1 equals 0.95 times Bn minus 1,200, where B 2018 is 120,000. Question A says, show that the expected number of nut trees at the end of the year 2020 is 105,960. So we know that B 2018 is equal to 120,000, which means that B 2019 will be equal to 0.95 times B 2018, which we know is 120,000, minus 1,200. Plugging that into a calculator, we should get an answer of 112,800. B 2020 then is equal to 0.95 times 112,800 minus 1,200, which, plugging that into a calculator, should give you an answer of 105,960, and then there's your proof. Question B. Actually, we're given a little bit more context before question B. It says, funnily enough, Squirrel Sanctuary contains a population of squirrels. Let Sn be the number of squirrels on the island at the end of year n. The change in the number of squirrels from year to year can be modeled by the recurrence relation, and then we're given this recurrence relation. Sn plus 1 equals 1.04 times Sn, where S 2018 is equal to 20,000. The squirrels of Squirrel Sanctuary have enough food so long as there are at least 5 nut trees for each squirrel. Show that Squirrel Sanctuary won't have enough food as of the year 2020. So, the number of squirrels in 2018 we know already is 20,000. The number of squirrels in 2019 we can find by finding 1.04 times 2018, which we know to be 20,000. Plugging that into a calculator, we should get an answer of 20,800. S 2020, the number of squirrels in 2020, we can find by doing 1.04 times S of 2019, which we know is 20,800. Plugging that into a calculator, we should get an answer of 21,632. So we know that the number of squirrels in 2020 is 21,632. We know the number of nut trees is 105,960. So if we're looking for nut trees per squirrel, we go 105,960 divided by the squirrels, 21,632. And that should give you an answer rounded to 4.9. So since 4.9 is less than 5, there will not be enough food. For the squirrels. Before part C, we have another little bit of context. In order to keep the squirrels well nourished, a team of squirrel lovers will plant extra nut trees at the end of each year. Let Tn be the number of nut trees on Squirrel Sanctuary at the end of year n. Let K be the number of nut trees planted at the end of each year. The change in the number of nut trees from year to year can be modeled by another recurrence relation, and we're given Tn plus 1 equals 0.95 times Tn minus 1,200 plus K, where T 2018 is equal to 120,000. Question C says, how many nut trees must be planted at the end of each year if the number of nut trees on Squirrel Sanctuary is to remain constant? In order to solve this, we could substitute a value for T 2019 as being the same as T 2018. So 120,000 being equal to 0.95 times 120,000 minus 1,200 plus K. Putting this into solve, 120,000 again is equal to 0.95 times 120,000 minus 1,200 plus k, and we're solving for k. Solving that, we should get a value of k that is equal to 7,200. So therefore, 7,200 trees must be planted each year in order for the number of trees to stay constant, or the number of nut trees, I should say. Question D says, how many nut trees must be planted at the end of each year if the number of nut trees on Squirrel Sanctuary at the end of 2019 is to be 2,000 more than at the end of 2018? Well, if it's going to be 2,000 more, then now we're looking for 122,000 is being equal to 0.95 times 120,000 minus 1,200 plus k. Once again, whacking this into solve. 122,000 equals 0.95 times 120,000 minus 1,200 plus k, solving for k. Now this should give us an answer of k of 9,200. Notice that it was just 2,000 more than the question before because we're looking for an extra 2,000 trees. So that would have been a fast way of getting straight to the answer. Since this question is only worth 1 mark, you can jump straight to just writing the answer, 9,200 trees. Question E says, what is the minimum number of nut trees that should be planted at the end of each year to ensure that Squirrel Sanctuary has enough food in 2020? Now this question is once again not strictly VCAR style, but it's a fun question to get you thinking and sort of working with these different skills in a way that isn't expected of you, but is helpful in terms of deepening your understanding of the topic. So we know that we're going to have in 2020 from our answer to part B, I believe, we know that we're going to have 21,632 squirrels in 2020. So the minimum number of trees that we need is 5 times that amount, which if we plug that into a calculator, we should get an answer of 108,160, which tells us that the number of trees that we're going to need in 2020 is going to be 108,160 at the minimum. So going through here, we know that the number of trees in 2018 is 120,000. We know that the number of trees in 2019 is going to be 0.95 times the number in 2018, which is 120,000, 1, 2, 3, minus 1,200 plus k. Now, of course, we don't know what k is yet. We also know that in T2020, this is going to equal 0.95 times 2019. So we're going to take this value of 2019 and substitute that in here, which is going to be 0.95 times 120,000 minus 1,200 plus k. So that's our value of 2019, which is then followed by minus 1,200 plus k. And we know that 2020 should also equal 108,160 if we are in fact to have the minimum number of trees required. This is a fairly long equation, but if we whack that into solve, so if we solve 0.95 times 0.95 times 120,000 minus 1,200 plus k minus 1,200 plus k equals 108,160, and we're solving 4k, whacking that into a calculator, we should get an answer of k equals 1,128.2 when rounded. And since we need at least 5 trees per squirrel, we can't round this number down to 1,128, otherwise we'll have less than 5 per squirrel. So we're going to have to round that up to 1,129 trees each year is the minimum amount that we need. Go Guys, if you have any questions about those answers, please drop them in the comments below. Otherwise, we'll see you in the next video.